All right, welcome everybody to the Our Blue Planet Earth STEAM Activity Toolkit unboxing webinar. It's great to have everyone here today. And sorry, I didn't update the slide from yesterday, but we began at 11 a.m. Mountain Time. We are recording this, so if you have to jump off at any point, you can check out the recording. It'll be posted on the NASA at My Library ALA Connect. For those of you just joining us, please introduce yourselves in the chat. I do want to point out that this webinar is structured as a meeting, so you do have microphone and video access. So at any time, if you want to unmute yourself to ask a question or comment on how any of these activities might work in your library, we would love to hear your voices. Otherwise, feel free to participate in the chat.
These can be put up here, right? Or are these something James is working on?
Good question.
Oh, okay. I don't want to put them all in.
All right, and I am going to ask, since you do have microphone access, please be mindful that you keep your microphone on mute, unless you would like to ask a question. So I'm going to go ahead and mute people for now. All right, and yeah, so some introduction. So my name is Claire Radcliffe-Adams. I am an education associate at the Space Science Institute, and I'm joined here today by Dylan and Christine, and I'll pass it over to them to introduce themselves.
Hey everyone, I'm Dylan Connolly. My pronouns are he or they, and I am an education specialist here at SSI, and I'm really excited to share some of the activities from the toolkit and show them off and demonstrate them for you today.
Hi, everyone. I'm Christine Shupla at the Lunar and Planetary Institute, where I have the privilege of partnering with Space Science Institute for NASA at My Library. We're glad to be here. We'll be talking a little bit more about ocean worlds as well as our ocean world.
All right, thank you. And I'll pass it over to Dylan to lead us through a icebreaker.
All right, so since this toolkit is all about oceans of possibility, water-based activities, and water is such a multifaceted, you know, take different forms, you can do different things on Earth. I thought, let's get our brains thinking about water and personalize this a little bit by thinking about what type of water you might be today. So we have 4 different options here, and I'm gonna read them out. But if you're feeling like one of these, or maybe a different type of water, go ahead and throw how you're feeling in the chat. Are you feeling like an ice sheet? Are you like really solid and steady? Maybe a little chilly? Are you a river? Are you steady, gentle, salty? Hurricane, are you powerful, energetic? How are you feeling? And why? Oh, gotten some oceans. That's promising. Claire's feeling like myself. I'm like a river today. I'm feeling go with the flow. I'm excited to see where this webinar takes us. We got rivers, hurricanes, a lot of oceans. All right, a lot of salty individuals in the house tonight. All right. Well, thanks for sharing, everybody. And I'm going to pass this back to Claire to talk a bit about what this toolkits are all about.
All right, thanks, Dylan, and thank you all for participating in that. Nice to get a temperature check of how people are feeling today. So this is the second of 3 activity toolkits that we're providing to the NASA at My Library partners. The first was for James Webb Space Telescope launch. And this one is called Our Blue Planet Earth. It fits in with the CSLP summer theme of Oceans of Possibility. However, we did try to include activities that you can do even if you're not focusing on oceans this summer. It's a bunch of activities you can do outdoors with your patrons and just, you know, celebrating our beautiful planet Earth. So this activity toolkit includes 7 interactive STEAM activities. Each activity comes with a blog that contains science information and how this activity fits into ocean science or other ocean world science. And they also contain video resources that you can share directly with your patrons. In addition to the blogs, each activity also includes a modification and preparation list. So these are different ways that you can maybe turn an activity into a take and make kit or do a virtual program for those of you who may still have some COVID restrictions. So definitely be sure to check out all of those additional resources. Here's an example of what you'll see when you click into the activity. All of these activities are on the Our Blue Planet Earth Clearinghouse collection. We're also joined today with my colleague Beatrice Chavez, and she'll be dropping a link bank into the chat that has links to this clearinghouse collection where you can find these activities, as well as direct links to these activities. So when you click into those links, this is an example of one of the activities called Investigating the Insides. You'll have a brief description of the activity. When you click Open Activity, that will take you to the guide. And then I wanted to point out down below this button that says Modification and Prep List. That's where you'll find those ideas for how to change any activity to a virtual program or take and make. Additionally, if you scroll down below that, you'll find under related links, the first link will be a link to those science blogs. So if you want to get that background information, it's kind of your cheat sheet for how to connect these activities to science. You'll find it there in related links. All right, so that's kind of a quick overview of the activity toolkit. Again, this is our second of 3 virtual activity toolkits. The third will be about the James Webb Space Telescope first images, and I'll have that ready for you at the end of May next month. But let's dive into some of the activities that we have in this one. The first, these are actually 2 activities that go really well together. So if you're trying to create a program, we highly recommend pairing these together. So the first is called Catch the World's Oceans. And this is a great icebreaker activity. So it doesn't take very long, but it's a great way to just introduce patrons into the theme of oceans and a way to get to know each other if you have a new group of patrons. And then the second one is Drop in the Bucket. So this is a demonstration that goes along with how much water we have on our planet and how much is actually usable for humans. So these are 2 activities we recommend going together in a program. So before we demonstrate the activities, we're going to talk a little bit about the science connection. So this is all information that you would find in the blogs, but I'm going to discuss it with you now. So how did we even become an ocean world? So it's thought that the ocean and atmosphere formed over millions and millions of years as the planet's surface cooled when it was a very young planet. Gases, including water vapor, escaped from the molten rocks as the planet cooled, causing rain to fall for centuries. So this water seeped into the crevices of the earth and accumulated as the ocean held onto the planet by the force of gravity. So that's kind of how we think we came to have such a big ocean. And I love this image here. Oftentimes when we see pictures of the globe, we're land animals, so we kind of focus on, maybe North America or some continent. So there's always a big piece of land, but that doesn't really show an accurate picture of our globe. This picture here is a NASA photo, and it centers on the Pacific Ocean. And when you look at this photo, you really don't see much land at all. So I like to put this out here and then ask you all if you want to answer in the chat, or feel free to unmute yourself. Kind of looking at this image here, how much of the earth do you think is covered in water? So you can give maybe a percentage, 50%, 20%, 100%. So feel free to answer this in the chat. How much of the earth is covered in water? Christina is saying maybe 20%, got 70%, 90%. All right, yeah, a lot of you are around that 3/4, 70%. We had someone say 90, over 90%, 97%. These are some really great estimates. And I also ask you to think, what are the different sources of water? So as we can see right here in this image, it would look like most of the source might be the ocean, but what are some other sources of water that we can find on our Earth? All right, we've got groundwater as a source, absolutely. Ice sheets and glaciers. Yeah, absolutely. So the ocean is not our only source of water on this planet. So I'm going to move on. So those of you who are on the 70%, you're accurate. Approximately 71% of the Earth's surface is covered in water. So that's about 3/4 of our planet. And in addition to the ocean, we get our sources of water from groundwater, ice caps and glaciers, the atmosphere. So you can see here a lot of clouds. So that would be water in the atmosphere, clouds, salt and freshwater lakes and rivers. So we have quite a bit of water on this planet, but of that 71%, how much do you think is usable by humans? How much? Yeah, 2%. A great guess, Teresa. 5%. Yeah, so you all, yeah, so Kevin, thanks for clarifying that. Yeah, how much is usable by humans to drink, to wash our clothes, to bathe ourselves in? How much, yeah, is drinkable? I'm seeing low percentages here, and you're all very close. Yeah, much of this water is not actually usable for us to drink and consume and use in our daily lives. So let's talk about how much is fresh. So of that 71% of our planet's surface, that water, only 3.5% is fresh water, but most of that is trapped in ice and glaciers. A lot of it is in groundwater that we are not able to access. So between all of the freshwater lakes, the freshwater rivers, and the amount that we can get from groundwater, the amount we can actually use on a daily basis is very, very small. It's way less than 1%. It's only about 0.0003%, which is pretty mind-boggling. So for a planet that is largely covered in water, it is still a scarce resource for us as humans. So these two activities, Catch the World's Oceans and A Drop in the Bucket, demonstrate just how much water, how little water we actually can use as humans. And they open up, there's room for discussion in terms of how can we conserve that small amount of water to use on a daily basis. All right, so that's kind of the background science connections to these two activities. The first activity that we're going to demonstrate is called Catch the World's Oceans. So this is that icebreaker. So I'm going to be joined by my colleagues Brooks and Beatrice. So I will stop sharing and bear with me for one moment as I switch cameras. All right, we have Brooks here. He's ready to go. I'm going to spotlight for everyone so you can see. All right. All right, so like I said, I'm joined here today with Brooks Mitchell, who's another education associate, and off camera we have Beatrice Chavez, and they're going to help me demonstrate this activity. So it's very simple. You need some sort of globe, not a hard one because you're going to be tossing this around at each other. This one is a Huggable. The brand is Huggable Globe. You can order them online. You can also find inflatable globes, but anything that you feel comfortable tossing around with a group of folks. And the way this game works is first, since it's an icebreaker, you can introduce yourself with your name, and you're going to toss the globe to the next person. And wherever they catch it, wherever their right pointer finger lands, if it's on water, they'll say water. And if it's on land, they'll say land. And you just kind of keep track of how many times the globe lands on water or land. So for round one, we're just going to introduce our names. And for round two, we're going to throw something fun in there, and we'll share our favorite water activity. All right, so we'll start. So my name is Claire.
All right. My name is Brooks. My finger landed on land.
All right.
The Baffin Islands.
That's one for land.
right.
My name is Beatrice and my finger landed on land. Oh, wow. All right. Again, my name is Claire. My finger landed on water. We got one for water. And for this second round, we'll say our favorite water activity. My favorite water activity is dancing in the rain.
All right. So my finger landed on water. And my favorite water activity, I might be running in the snow.
My finger landed on land. And my favorite water activity is snowboarding. All right, so that's the game. Normally, if you have multiple people and you play a few rounds, you'll start to notice that more often than not, your hands land on water. Today, we actually have 3 lands. So
Does that mean there's more land than water on Earth?
well, I think if we play a few more rounds, we might see the data shift.
I bet so.
Yeah. But that is Catch the World's Ocean. It's a really fun way to break the ice and introduce the topic of how much water we have on our planet. So thank you, Beatrice and Brooks. I'm now going to pass it over to Dylan to demonstrate a drop in the bucket.
Thanks, Claire. If you could go ahead and spotlight for me for everybody, that'd be great.
All right, you're good to go.
All right, so here we have the materials for a drop in the bucket, which is a really great activity that's a nice demonstration of the proportions of different types of water, as well as the total usable water by humans on Earth. So here we have a 5-gallon bucket filled up with just water from my sink. And what we're going to do is we're going to take out proportionally, if this 5 gallons represented all the water on Earth, we're going to take out a little bit at a time that's going to represent all the different sources of water on Earth. So first we're going to take out what would represent the ice caps and the glaciers, which if all the world's water is about 5 gallons, that's going to be about a cup. And I recommend having a clear container that you can put all this water into, so everybody can see it compared to the ocean. So we're going to pull out the ice caps and glaciers, which is once again about a cup, about 2% of the total water on Earth. Then we'll pull out the groundwater, which is about 1/3 of a cup of this 5 gallons, or about 0.62% of the water on Earth. We'll pull out fresh water and lakes, which, believe it or not, is only 0.009%, or about 1/8 of a teaspoon. I'll pull out half this 1/4 teaspoon, throw that into our collection. And then the inland seas and salt lakes is about 0.008%, about another 1/8 of a teaspoon. Then we're going to pull out all the water in the atmosphere, which is about 0.001%, or about 1/100th of 1% of a cent. And that is just one drop of water. And then all the rivers on Earth is 0.0001%. And that's just a tiny flick. So I'm going to get my finger wet and flick that into our container. So here we have all of those fresh water sources on Earth. And then the rest of this represents the ocean. Or sorry, not just fresh water, but all the non-ocean water sources are in here, because it does contain salt lakes. Now let's put back everything into this bucket that is not usable by humans. So we are going to put back the ice caps and the glaciers. So it's going to be that cup. This activity, especially if you're going back and forth, I highly recommend using a container with a force mount. Makes it a lot easier to get those back and forth. So we'll add the ice caps and the glaciers. Now, some groundwater is usable by humans through wells, but most of it is trapped underwater in groundwater deposits. We're going to put most of that 1/3 cup back in there. Then we're going to take the inland seas and the salt lakes, which is that 1/8 of a teaspoon. Add that in there. And then the atmospheric water, which is that drop. So as you can see, there's very, very little water left over that's usable by humans out of the total of this 5 gallons. And so this is a great opportunity after you've done this demonstration to start talking about ways that people can preserve water, time your showers, try and prevent pollution. Don't pour things out that are pollutants into sources that lead to groundwater deposits or out into freshwater reservoirs, things like that. And is a great pairing for other types of conservation activities. If you're doing any citizen science activities, activities or long-term conservation activities, this is a great kickoff to those kind of longer-term programs. So that is a drop in the bucket, and I'm going to hand this back to Claire to talk about the science behind clouds.
Awesome. Thank you, Dylan. I love how visual that demonstration is. It's really hard for me to comprehend, what 0.0003% is, but to be able to really see a comparison, I think is great. So, all right, so that was Catch the World's Oceans and a drop in the bucket. So that's our first 2 activities out of the 7. Next, we have 2 activities that are, again, great to pair together. The first is Globe Observer Clouds, which is a citizen science project. And it really gets you outside and your patrons outside looking up at the sky and collecting data that actually goes into a citizen science database. So, and it is really helping scientists understand what's happening in our skies. And this can be paired with an art project called Cloudscape, where you use pretty much found materials, but things like cotton balls, fabric strips, wax paper, and you create a collage of what you see in the sky. So let's start with those science connections. So first off, just to connect to your own life, if we have any cloud watchers here, what do you like about looking up at the sky and observing the clouds? Something you enjoy, or what types of things do you see? Yeah, Liz says gets your mind off of other things. It's calming. Dylan likes looking for shapes in the clouds. Yeah, to your point, Alice, I used to say, I just love watching the movement of the clouds across the sky. And I used to say, if you're not noticing the clouds move in the sky, I think you're moving too fast. So it's a way to kind of take a step back. Yeah, absolutely looking for shapes. People are saying they like cirrus clouds. I really like cirrus clouds as well. And absolutely, Lisa says different colors. Yeah, the sky is so dynamic, and throughout the day, so much is happening, from sunrise to sunset. Kevin, what's not to love about clouds? Absolutely. It's something that almost everybody can participate in, right? You don't need a whole lot of equipment. You just need to get outdoors, and it doesn't need to be a blue sky day, to enjoy cloud watching. Some of the best sky watching is when storms are rolling in. All right, and Barbara's already kind of getting to my next point. What can clouds tell us? Barbara says, I like to try to guess where the winds are coming from. But what else can we infer from our observations by looking at the sky? What can clouds tell us? Weather, absolutely. What is happening? What is coming? It's great to make predictions. What's about to happen with our weather? Excellent. So of course, we look at clouds every day. Sometimes I take them for granted. They're just up there, these fluffy things in the sky. But they're actually tiny droplets of water formed into a mass, and they do connect to oceans because it's water that comes originally from our oceans. The water rises, turns into vapor, cools, and then turns into droplets. And of course, as you guys said in the chat, clouds can tell us about all kinds of weather. It's just about knowing what you're looking for. So you all are familiar with our 3 main cloud types. We've got stratus, which are those layered clouds, cirrus, wispy clouds way up high in the sky, which are personally some of my favorites as well. And then the cumulus clouds, those big puffy clouds you see in the sky. My husband calls them Simpson clouds, but there's those beautiful, big, robust, puffy clouds. But beyond just those 3 types, altitude is a part of this story of trying to figure out what we're seeing in the sky and how it can inform our predictions on weather. So cirrus, we will mainly find that way up high in the sky. And any cloud that is above about 20,000 feet uses that term, cirro, in front of it. So you can have cirrostratus clouds, you can have cirrocumulus clouds. Yeah, so that means it's very high up in the sky, and because it's so high up, the temperature is very low. So these clouds are actually ice. Next, if you get to the mid altitude, so this is between about 6,500 feet and 20,000 feet, we put the word alto attached to those clouds. So you can have altostratus, altocumulus, and those are clouds that are a mixture of water and ice. And finally, our low clouds have the word nimbus attached to it, and this means water. So these are clouds that you will have precipitation from. So you can have nimbostratus, which is fog-like, and you'll have that steady drizzle throughout the day. If that's what's happening where you're living, then you have nimbostratus. Or we get out here in Colorado quite frequently cumulonimbus clouds, which are those big thunderheads, and they produce really intense storms. But that only happens with clouds below 6,500 feet. So these are the lower clouds, and they're all water. This little chart that you see here comes with the activities, and it helps your patrons to understand what types of clouds they're seeing, and it can help them to create their own cloudscapes based off of this little guide. And then of course, humans are kind of part of the equation as well. Way up high in the sky, you might see contrails, and those are ice that has formed around, ice crystals that have formed around exhaust particles from airplanes. So that's also could be part of your collage when you're creating a cloudscape. Maybe there's contrails up there as well. That's just a little bit about the background science. Again, you can find all that information in the blog. But I'm going to turn it over to Dylan to talk about the Globe Observer Citizen Science Project you can do with clouds.
Excellent. Thank you so much, Claire. So the Globe Observer program is a series of citizen science programs that NASA has put together where people all over the country can go out and make observations in nature and report those observations back to NASA. So we are focusing on the clouds portion of the Globe Observer program, but there's also a mosquito program, land cover, and trees. And these are really, really great citizen science programs that you can run at your library. So there's kind of three ways to do this activity. You can do this like in person. You can get a bunch of, either have people bring their own smartphones. If you have a collection of tablets at your library, you can load this app onto some tablets and do this as a program. You can also do this kind of long term, have people make several observations and track their observations over the course of a month or longer. You can use this as a take and make kit. There's tons of promotional activity materials available on the mod and prep list, where you can send people the Cloudscape activity supplies as well as instructions on how to download the Globe Observer app. And then they can pair making those observations and then recreating their observations through art. You can also do this as a virtual program. Christine has put together some fantastic videos on STEAM strategies, and there's a really excellent one on running virtual programs. And this is a great opportunity for, if you are still doing virtual programming due to COVID, to set up some great programming where you can interact with your patrons, do citizen science, and do STEM programming while still being fully virtual. So I'm going to walk you through, I'm going to show off the how-to video that's included on the activity page and in the blog toolkit, which is going to walk you through how to do one of the observations on Globe Observer clouds. So you're going to find a nice outdoor space. Highly recommended you wear appropriate clothing, especially if it's still in a chilly part of the country. So like we said, this is all about creating real observations and sending those observations to NASA to create a huge data set. So when you create your first observation, you're going to open the app and choose clouds. You're going to need to register first, so that's kind of important thing to keep in mind before you start this. And then you're going to verify your time and location. The app is going to ask you what the sky looks like, and you can go, you're going to estimate the rough amount of cloud cover and obscuring features. So you're going to look in all directions and make a general observation total, not just in one location. Then you're going to look for the deepest blue that you can see in the sky and record that. From there, it's going to ask you about visibility. You're going to estimate how clear or hazy the day is as you're making your observation. And then you're going to look, this is where the cloud identification chart included in the toolkit would be really helpful. You might want to use that to help identify what types of clouds you're seeing. This is also information that's available in the app. Then you can record the opacity, which is how much light is passing through the cloud, and the general conditions on the ground as you're making these observations. Then you're going to take a photo. And what's nice about this is the app itself will access the camera app, and you'll have a little button that you will line up with the center of your camera view to get a full 360 view of the sky in your location. And then you can send your observations to GLOBE observers, and they'll be shared with researchers and other citizen scientists. Now, what's nice about this is even if you do say you have tablets, but maybe they're Wi-Fi only, you can record the observation and then send that to NASA later once you're back under Wi-Fi or you have data connection. So now I'm going to show you off what this app kind of looks like in real time. So this is the cloud section of the Globe Observer app. You have two kind of navigation menus here on the bottom. To the left, you have the button that'll take you all the way back to the Globe Observer home screen. Here's all that intro text again. You also have, you can easily pull up that button with the bar graph. Will take you to all the observations you've made over the entirety of the app. So once you're inside clouds, you have the observation to make a new cloud observation. The green button here will allow you to review and send the observations just from the cloud. Another great thing is you can check satellite flyovers. So you can check and compare your data against NASA satellite flyovers, see if yours agrees with the satellite assessment. And there's also great data for NASA to compare the surface conditions with those satellite observations. So this is a great way if you're planning on doing this kind of programming, setting up, using this as a timing schedule. Say you're looking for one for an after-school teen program. This is a great way to align this with some other stuff that you can do. You can also check those satellite flyers. You can also get alerts for solar noon, which is not necessarily the same as clock noon, as time zones and things like that affect, and daylight savings time can affect when exact solar noon is. So you can align this with solar noon, which is another helpful data point. And then you can also set alerts for those upcoming flyovers, and yeah, so that is a great app that pairs really, really well with the Cloudscape activity, the Cloudscape art activity that Claire is going to tell you about now.
Awesome, thank you, Dylan. I'm going to switch my camera. You can see this okay. All right, so Cloudscape is a fun way to integrate.
Can you pin your camera? We're seeing Dylan big, and I'd like to be able to see your camera big.
Yes. Give me one moment. Thank you for that reminder.
Sorry, everyone just got a big view of me chugging my water.
All right, I think that's better there. All right, so Cloudscape is a way to integrate the A art into STEAM. And this is something you can do maybe after you take your observations using the Globe Observer app. It's also really easy to take and make activity. You just put a bunch of craft materials and blue cardstock into a bag and send it out with your patrons. But for this, there are basically 3 steps. You have your patrons look up at the sky and then create a collage of what they saw. That's step 2. And step 3 is to label the clouds, the different cloud types. So you can use that guide that I was showing earlier in the Science Connections, you can print that out and have that available for your patrons to identify what types of clouds they're seeing. So on mine, I had, we have cirrostratus way up high in the sky. So that's those layers of clouds. And I just used strips of paper for that, just shredded paper. There was an airplane flying overhead. So I drew a little airplane and I have a contrail and I made that out of wax paper, which I really enjoy for this activity because it kind of gives that like ethereal, like disappearing type of look. We had some fluffy clouds up about halfway in the sky. So those are our alto cumulus. So they're between 20,000 feet and 6,500 feet. I just used some cotton balls for those. And then we had some cumulus down a little bit lower. And then finally, for a day that's kind of stormy, I have a thunderhead here. So this would be, let's see, I had a label for it. Here it is. Our cumulonimbus. So remember that nimbus means precipitation. So I'm going to go ahead and glue that label on my lower level below 6,500 feet cumulus. That probably is telling me it's going to rain later today. Another fun thing you can do is incorporate color. Someone in the chat was mentioning how important color is for telling you what types of storms might be coming, like a tornado. So you can include markers. So for this one, since it's a little stormy, I have a gray marker here. I'm just going to shade in the bottom of my cumulonimbus cloud to kind of demonstrate that we've got some stormy weather coming up. So you can make that a little bit gray. Of course, maybe you're doing this at sunset and you can include some pinks and oranges and really just make it whatever your sky is looking like at the time. But that's Cloudscape, a fun way to bring in art into learning about clouds. All right. Before
I just love the tactile nature of this, the way that you can arrange things and incorporate the content and the different materials. And I was wondering if people might want to enter into the chat any changes, what types of materials you might use, how you might modify this, or what materials you might use. For instance, I've seen some people use like feathers and things like that. So.
Yeah, that's a great question. Yeah, so here I put some the list of materials that I used. But yeah, I would love to hear from you all. What do you think you could use to do this art activity with your patrons?
Or is it too messy? Glue and things. People want to stay clear of glue. We understand that too.
What I think is great about this activity and the next one, building for hurricanes, is that it's a really great found object or leftover materials kind of activity. If you've got anything relatively fluffy or could be turned into fluffy, this is like if you've got some like, you know, almost empty rolls of paper towels, shredding those and ripping those up and, you know, emphasizing their fluffiness is a great cloud material. Shredded in the photo here, there's some shredded old terry cloth, you know, if you want to cut around some stains of an old bath towel. And
glitter is so hard to clean. Absolutely. Yarn, nice.
use that for a cloud activity. Cotton ball. Oh, yarn is another fantastic example.
And someone mentioned felt as well. Yeah, so sounds like a lot of you do activities like this, and hopefully this can be something useful that you incorporate into your programs. All right. So we are going to move on to the next activity. This is an engineering and design activity called Building for Hurricanes. And I'll turn it over to Dylan to talk with you about the space connections and do a short demonstration.
All right, so for hurricanes is a activity that is all designed around thinking about creative problem-solving engineering, specifically related to how to build buildings to withstand the force of hurricanes. So let's cover some background science. So what is a hurricane? A hurricane is a storm with wind speeds of at least 74 miles an hour, and they're formed by a cycle that is created when warm air near the ocean surface starts rising, which then pulls down cooler air from the atmosphere. And that warm surface water then cools that cool air, pushing warm air back up into the atmosphere, pulling down cooler air, creating this convective cycle of heat that creates these really, really large, massive storms. Can we move on to the next slide? So one of the issues, especially as storms like hurricanes become more and more frequent due to global climate change, civil engineers have to design buildings to be both wind and flood resistant to withstand the side effects of these hurricanes. So some strategies that civil engineers use include allowing air to flow through buildings, creating air channels so that it's not just the force of the wind is just hitting the building head on. It allows some of that air to flow through, which lessens the impact of that wind. And also elevating buildings above flood lines. You see this a lot in hurricane-prone areas like Louisiana or Hawaii. You will see a lot of homes on stilts and raised up to be flood-proof. And this is, like I said, this is increasingly a concern as storms become more powerful due to climate change. There are 3 parts to this basic activity. There are design and capture sheets. You're going to ask your patrons to design their hurricane-proof building, and then you're going to build it with whatever materials you have. Some example materials. We'll show some example materials on the next slide. And then you're going to test it. The basic test is whether or not your building can support a tennis ball, which just kind of shows basic structural integrity. But then you can also test it with a spray bottle and a wind to represent some of that wind and water force that's going to be involved in a hurricane as well. Can we go on to the next slide? So just like with Cloudscape, this is a fantastic activity to use some found objects or to seek some donations from your patrons. Things like toilet paper rolls, paper towel rolls, pipe cleaners or Chanel stems, plastic straws, index cards, tape, as well as providing some basic tools like a straight edge or ruler or some scissors for them to kind of cut and edit some of their materials are also really great. Move on to the next slide. And to test it, you're going to need that capture sheet, which also is the same sheet you're going to design the buildings on, a spray bottle for spraying some of that rainwater, a tennis ball to test the structural integrity, and a fan. Now, if we go ahead and spotlight me once more, I'm going to show off a couple of towers that I made to show off what this might look like when you test it out. So here's the first tower I've made. And this is basically out of some toilet paper, masking tape, some index cards. What's great about this activity is if you're limited on supplies or you want to run this activity multiple times, you can shift up what type of materials you're using. You can give them access to any materials that you might have in the library, or you can give them limited materials. Maybe you give them unlimited amounts of masking tape, but they only get 2 paper towel rolls or just a couple of index cards to use. So there's some ways to run this over and over again and still have some different challenges or different requirements so you can run this program multiple times. So we'll go ahead and check this tower for, it looks like it's supporting that tennis ball fine. Let's go ahead and turn on the fan, see if it's going to resist some of this wind. Oh, and I've got my fan up to the maximum and it is not blowing over our tower. Let's see if we add some, is my camera freezing again? Did that freeze as well? Let me see if I can fix that real quick.
You're good. Oh, it did freeze, yeah.
Okay. There we go, better now.
Yeah.
Decided to be activated. All right, so let's check that wind force. And we're adding some rain. And it looks like this tower is good. All right. So now, what's also nice about this activity is you can also have them redesign their tower if it doesn't work out the first time. So let's explore what that might look like. Say this is a patron tower, maybe a younger patron has made, and they've designed it and they're like, I'm going to put this on stilts because I know that I wanted it on stilts, but maybe it's not exactly even, it's not holding up itself. And as soon as we test it, we turn on that fan, the tower goes bye-bye. So give them an opportunity, it's a great opportunity to practice iterative creative thinking. So turning on my fan over and over again. Maybe you could start with this as a basic design, but maybe add some chenille stems that might help give it a little bit more structural integrity and might hold that tennis ball as you're doing that first test. So if we add those chenille stems, as I might if I'm retesting this, look at that, it's actually holding the tennis ball, sort of, or maybe not, as I came out the bottom. But as you can see, there's an opportunity to provide lots of different opportunities for patrons to test these hurricanes in different ways, iterate them in different capacities, and also try again, come up with different design strategies based on limited materials. We had an idea in our last webinar. If you live in an area with wind chill, maybe testing out how, if you have access to a freezer at your library, having them design their tower, put that in the freezer for a certain amount of time, see how that affects the materials you built with. The adhesives on masking tape, for example, get a little less tacky as you put them in cold temperatures. So that's a great way to explore how materials might be affected by weather conditions in your local area. So that is building with hurricanes, which is a really fun activity. And we will now pass this back to Claire to talk a little bit about polar bears and ice caps.
Great, thanks, Dylan. We do encourage you, if you do modify this activity to be more locally focused where you are, let us know how it goes. We'd love to hear any modifications. So if you're doing something to test for tornadoes, please post it on ALA Connect so we can hear how it went. All right, so our next activity is called Polar Bears Go with the Flows. This is a board game that is collaborative, meaning that you all work together and you all either win or you all either lose. And it is a way to talk about our Arctic ice sheets and what's happening with them up there and how human influences can either be harmful or maybe helpful, depending on how the game goes. So talking about some of the science connections. So the ice caps of the Arctic and Antarctic are important regulators of the global climate, but also of ocean temperatures. So this does have a direct correlation to our ocean. Not only that, but sea ice provides vital habitat to animals, of course, such as polar bears, but also all kinds of other animals. So you can bring in a tie-in to ecology that way. Human activity is contributing to climate change, and this is causing a decline in sea ice. So you can see on the right-hand side here, that is Arctic sea ice coverage in 1984 on the top. And then on the bottom, that is showing Arctic sea ice in 2012. So there has been a decline in sea ice in the last 40 years by about 40%. So this activity does start talking about some of these issues. And so that, with that in mind, it is an activity that is a little more appropriate for about tweens and older, just because it can be a little heavy, you know, talking about the changes that our Earth is going through. And younger kids might not be developmentally ready for those conversations. But it is a great family game as well. So if you do have younger patrons, they can still be a part of this by talking about their favorite animals and being a part of the game. But yeah, so that is some of the science connections behind this activity. I'm going to stop sharing and spotlight Dylan again. He has created the board game and he'll walk you through, you know, how easy it is to create this game. It's mostly just printables, and walk you through the steps of playing the game.
Thanks, Claire. So this is the basic setup you'll need for Polar Bears Go with the Flows. What's great about this is if you've got access to you know, a $10 package of cardstock and a printer at your library, this is easy to create with just a printer, some scissors, and a glue stick. The only outside thing you're really going to need is a six-sided die, which is a really common thing. I'm sure most of you have those around your library, and the printed materials. One tip for if you're going to make the ice flow puzzle, you printing it twice, once to use as a guide, and then once you wanted to create the puzzle pieces. The mod and prep list suggests maybe putting this on some foam core. You could print this on heavy cardstock. Or what I did was I just glued the puzzle to an old cardboard box, the side of an old cardboard box I had around, and used an X-Acto knife to cut out the pieces so I could have some bigger, chunkier puzzle pieces to go above the stencil guide. The game pieces, both the polar bear and the player game pieces, I just printed on cardstock. You'll see that you can print it twice and glue them together and fold. You'll see once you print it, you'll have that little square you can cut out, glue both sides to each other, and then just fold the bottom, and it's built in to have a nice little stamp. So the gameplay is pretty simple. You set up the board just like this. You print the board. Included in the PDF and the activity guide, it's recommended to print this page separate by selecting fitting it to the page size so it doesn't print over multiple pages. The game pieces you'll need to print the 3 sets of cards, the green points, the eco facts, and the eco blooper. And if you want to print this landing pad for the cards, you can do that as well. So determine who goes first. Simple way is to everybody rolls, highest goes first, and you can go clockwise. And then you're just going to start here on the starting square and then work your pieces around until you get to the finish. As Claire said, it's a collaborative game, so either everybody wins or everybody loses. And the win by you get everybody around and to the finish without all of the ice flow pieces disappearing. And you do have a big winner if somebody has the highest amount of green points as you go around. Eco facts are interesting factoids, which contain a lot of really interesting ice and ocean and climate science. And then you have the eco bloopers, which when you land on that page, you can either, you're one of those spaces, you can either pay the number of points indicated on the square, which can be anywhere from 10,000 to 30,000 if you're closer to the finish line. You can go back 5 squares or remove a piece from the ice flow puzzle. So you can kind of budget that. And that's a great thing for, especially since this is collaborative, if you're doing family games, encouraging those kind of conversations as you're walking around. Guide on a side style is a great way to facilitate this if you're running maybe multiple of these board games at an event. Everybody loses if the ice flow goes before all the players have reached the last square. And that's the basics of the game. Really, really nice and simple. So you can either print these, run this as an activity at maybe a family night, compare this with a other event and have this maybe in a quiet room. This is a great low key if you were setting up a sensory room for anybody who might have sensory issues at an event. This is a really great low key sensory room activity. And it's also, you could turn this, if you really wanted to, print this on some nice quality cardstock, maybe glue it to some poster board and turn this into a circulation item if you wanted to, or maybe some to pair with some of your ocean summer reading activities that you might be going on. And that's Polar Bears Goes with the Flows.
Great, thanks, Dylan. Okay. So we have one more activity to share with you all today. This is actually going beyond our Earth and talking about other ocean worlds, called Investigating the Insides. And I will turn it over to Christine to tell you more about this.
Thank you, Claire. So my first question for everybody, and I'd like you to answer, you can unmute if you want to and share your answers verbally. I'd love to hear from you, or you can put it in the chat. How many of you know of other ocean worlds besides the Earth, other places in our solar system with liquid water? Can you think of any planets or moons or dwarf planets or asteroids that might have lakes or oceans of water? Not necessarily on the surface, though. Does anyone know any of those? Have you heard that we're looking for liquid water in other places? Kevin asked whether it might be some on the moon, and Lisa said Enceladus. Awesome. Good points. One of Jupiter's moons, Teresa, and Europa. Europa is the moon of Jupiter, absolutely. And are we hoping to find it on Mars? We are. We're hoping that maybe there might be some places on Mars underneath the surface where there might be liquid water. Pluto, absolutely, Claire. Daniel, Europa. So all great answers. Europa is one of the most famous of these. It's an ice, and here in this graphic, you can see sort of the idea. Europa and Enceladus both are have thick oceans around an icy shell. The outer shell is ice, and underneath that, oceans of salty water. Pluto has something like a liquid underneath. It might not be water, but it's definitely got some sort of liquid. And they weren't expecting that. They were very surprised when the New Horizons mission discovered that. Kevin, yes, we're finding that there's types of water on the moon, but it's more in the form of water locked into the rocks rather than liquid water. So not liquid water on the moon, but there is frozen water at the moon's poles and water locked into some of the rocks. And yes, we're hoping to find it on Mars. Maybe there's a possibility. There's the slightest possibility that there might be some groundwater on Mars in some areas still. And this is important because water is one of the ingredients for life. Everything on Earth that has life. We found life in really weird places: the desert, high desert, low desert, Antarctica. We've found life, microbes in all sorts of remote places, but every form of life on Earth, including the weirdest, most bizarre forms of life, including little microbes, they all need water at some point in their life cycle. So water is important. And so all of these different places that you all have suggested qualify as ocean worlds. And so for investigating the insides, we're going to be examining these mystery balls or balloons as a model for how we study the inside of these different things to try to figure out, is there water in there? What else is in there? What are they made out of? And so the goal is to use our senses and also to use instruments to kind of infer what's going on the inside and to model how we study planets and moons and asteroids. And so your patrons would make inferences from their observations and compare this to how we study planetary bodies. Next slide, please. And so you might want to start by asking them a little bit about how we studied the insides of things. And some of them would say, oh, well, we send a probe down inside. We don't really, with the exception of dropping the Galileo mission into Jupiter and studying just the top cloud layers. And right now we've got a mission called Insight on Mars that is studying Mars quakes to try to learn a little bit more about the inside of Mars. But for the most part, it's hard to study the insides of planets, right? We aren't able to just look inside of them. But you can study the insides of something like a can by sort of shaking the can, by swirling it, by seeing how it feels, how things move, or a box. When you get a Christmas box or a Hanukkah box or a box for any sort of celebration, a birthday present, you might shake it to see how it feels and how it sounds. Well, you're going to have them do the same thing with these mystery planet models. Shake it, feel how it feels, how it shakes, what noise they hear, measure the temperatures, see if there's a magnetic field, see if there's something in there that tells you that there's metal inside of it. And you could refrigerate them or freeze them. And Dylan's going to tell you in just a second how to make these. I think we've got one more slide first, though. And so as they've got it and as they're playing with it, you can ask them to describe, well, what do you think it's made out of? What do you think is inside of it? How is it distributed? What does it sound like? What does it feel like? Can you test for a magnetic field? It's up to you whether or not in the end you're going to tell them what's actually inside of it. You can say no, scientists don't get to pop their planets and know for sure what's inside of them. That's how science works. You make an educated guess and inference based on the data that you're able to gather. And we're constantly gathering more information. As these missions are going around a planet, they kind of feel the tug. And that tug of the planet's gravity, how it changes, tells them a little bit more about the structure inside and how the mass is distributed. They have magnetometers to study the magnetic fields. They look at what the outside is made out of. And then we do look at little bits of popped planets, meteorites that have fallen to Earth from asteroids that have broken apart in some cases. And that tells us what used to be in the middle of those asteroids. We have materials on the surface of the earth that came from inside of the earth that tell us a little bit more about the mantle. So, so we have some ideas, some information. So it's up to you whether or not you want them to actually know the answer or get to peek or not. Does anyone have any questions for me before Dylan shows you how to make these? And if you can think of any questions, please put them in the chat. Dylan, on over to you.
All right, thanks, Christine. So Claire, if you wouldn't mind, I'm already spotlighted again. So like Christine said, there's many ways to make these kind of faux planets. You can get those kind of plastic clear balls that kind of twist together, fill those, wrap those in aluminum foil, or you can use balloons. If you're going to use balloons, I highly recommend using an opaque balloon. Metallic balloons in particular are really great for these. I have some metallic blue ones right here. The metallic coating, because it's meant to be kind of semi-reflective, is really great at keeping the balloon opaque even when you blow it up. But if all you have access to is some kind of see-through balloons, you can also double them up to create more obscuring planet, so they can't see, your patrons and your participants can't see what's inside the balloon. So I'm going to walk you through that process real quick. So you're going to start with a couple of regular balloons, and you're going to inflate them kind of a little bit past what you want them to eventually be, just so they're a little stretched out. If you have any some breathing problems or any lung capacity issues, you can use a hand pump or an air compressor to do this really, really quickly. So once I've pre-inflated my balloons, I'm going to take the balloon that I want to be the interior balloon, and what I'm going to do is kind of roll it so it's kind of in a tube. And what you can then do is take the neck of the other balloon and kind of work this in there. And what I do is I kind of twist it as it goes down in this tube shape and push it down, and it'll start to go in until you have most of that interior balloon lined up, and you can kind of pull the neck of the balloon up so that the lips of the neck of the balloon, that belly button of the balloon, is nice and equal. So once you've got the two lips of the balloon aligned, and you should have most of your balloon inside the other one, you can just give it a couple flips, and that's going to push that other balloon down inside there, and you've got two balloons nested inside each other. From there, you can test inflate this again just to make sure you've got it all down in there. And there we go. I've got one balloon inside the other, and as you can see, if I hold this up to the light, really hard to see through. Ooh, scaring my own camera with the base. All right. And from there, you can go ahead and fill this balloon with whatever you like. We have some example materials right here, some marbles, paper clips, some shredded paper is a really great thing. You can also add some water to create some sloshing effects, which will change the balance of those videos, those balloons. And here I've got some pre-made ones. Show you how we can test those. You can invite your patrons to test them a variety of ways. Weighing on a simple kitchen scale is great. Examining them up close to make some visual observation. Or if you're planning on including anything magnetic in here, for example, I put a magnet in this balloon. As you can see, I've also included, this is a really fantastic measurement tool. These are LCD temperatures thermometers that are adhesive. They're meant for doing things like aquariums and things like that to monitor temperatures of aquariums. You can have them test the temperature of your faux planets. If you are, say, putting water in with some of these and having air in others, that's a great inference indicator. That's a double evidence that there might be water in there. Water is a little cooler, might maintain a cooler temperature on that LCD display than the air. And then they can also feel that weight difference, the way that it sloshes and makes that visual reference as well. If you want to include magnets in here, I highly recommend using getting a compass to do the testing. If you put something strong like a cow magnet, like these kind of magnets in there, these kind of strong cow magnets, if you use a magnet for testing, that can pull the magnet really sharply to the edge of the balloon, and metal hitting metal inside a balloon, usually not the best for maintaining balloon integrity. So if you're concerned about balloon poppage, be sure to use a compass as you get close to that. That's not the one I put the magnet in. I put the magnet in the other one and I'm lying. Okay, well, let's pretend I put a magnet in one of these. The compass, because it doesn't have a strong magnet in, that compass will point towards the balloon instead of magnetic north. And that'll be a better indicator that you can, for magnetism inside those balloons, rather than that popping cow balloon. So that is how to make the investigate the inside balloons.
Great, thank you so much, Dylan.
And we should add a couple of things. Some of you have indicated that you've done this activity before, and that's great. If you do balloons and there's a chance that they might pop, there's a few things you might need to be prepared for. If you've got families with small children, keep an eye on that, because some of the items in there might be choking hazards. Anything that can fit into a balloon is a choking hazard, and something like a magnet could be very dangerous if a child swallows it. So, and then also, of course, if it's got water, if you put water into it and it pops, you might have a bit of an issue, a bit of a mess. And if you've got a magnet inside and you use a magnet on the outside and it's a balloon and there's water in it, a magnet against a magnet might quite possibly pop. We've experienced that on video before. If you're doing the plastic eggs, Atlas mentioned, using the reusable plastic ornaments, and you want water in it. What I've done is I've made I've taken a balloon, put some water in it, tied it off, and put it in the plastic ornament. So that way I've gotten a little bit of a water balloon inside of my plastic ornament. And some are very sensitive to the sounds, and it will make many of us jump up in the air and scream and things like that. So.
Great. Well, that was the last activity. So thank you all for sticking with us. That's a lot of activities to run through. I am going to launch a quick poll because we'd love to hear from you which of these activities you are most excited about. So
while you're doing that, I think you were also, Claire, going to ask two of our mentors who have joined us to share a little bit about their thoughts too. Yeah.
Absolutely. Yeah. So while you guys are thinking about which of these activities you could see doing in your libraries, and please, you can select more than one. I want to invite Kevin and Atlas, who are our NASA at My Library mentors. They've been putting a lot of their modifications and ideas in the chat. But if you would like to unmute yourself, Kevin or Atlas, we'd love to hear how you have done these activities or how you might modify them for your patrons.
Sure. I'm Atlas. Most of the things I feel like I had wanted to mention were covered pretty well. You guys did an awesome job. I know someone mentioned that the Globe Observer activities were a great opportunity to get people outside, and I definitely agree with that. We did them a few ways. We did them as a take and make, and we did them like with an accompanying virtual program, but we also did it in person because the branch I was at had a trail that ran around the building. And so we went out with tablets if people didn't want to use their phone, and we kind of made our observations together, and it was a lot of fun. And one thing that I loved about that is it's really a jumping off point for citizen science. So it was a good way to introduce that concept to kiddos. And it made them feel really special because we tried to make them understand, like, you are real scientists, you know how to do experiments, you know how to make observations based on that. But that really made them feel like they're real scientists and the data that they were putting in was making a contribution. So that was kind of like a special, unexpected thing that I didn't really anticipate initially. So it was meaningful to them in that way. And then I wanted to mention, I've done the investigating insides a few times, and Christine, I had never ever thought of not showing them what was inside. But that was a good point. But I will say, if you do it, I don't know if anybody has kids or works a lot with kids and they're really into those surprise egg like videos and toys and things like that. That's kind of what it was like at the end. They did, but with science. So they did their experiments and observations, but at the end, they were just so excited to see what was inside, even if it was just like ice or a magnet or a bunch of paper clips or whatever. So that one was always fun because it had a reveal at the end.
And if Drag Race has taught us anything, we love a reveal. That's
I know, but now I feel like I should, Christine is right, like that you don't really get to know, like you can't go over and test Europa and like see what's inside. So I'd never thought of it that way, but
I mean, it's up to you, really. Ultimately, it's up to you. You can do it. You don't have to. It's entirely up to you.
I guess it depends on the age of the kids I was doing it with. If the little ones, you definitely want to let them see what was inside. If they're older, they might be okay with you being like, no, we're gonna go.
There are adults who will get quite upset if you tell them that they're not allowed to look inside. So.
That's true.
well, and what's great about that activity is you can cater it, engage it to your audience in your library, and also what kind of programming you want to do. If you're going to be really discussing long distance observations, if you're maybe wanting to use this paired with some JWST first image stuff and talk about how scientists make different inferences about things that are really, really far away from abstract observations, that's a really great way to talk about this. If you're going to be maybe pairing this with some stuff about the Artemis mission and talking about manned missions, you can do the reveal and talk about how we go from inferences to on-the-ground observations once we get to do manned missions. So there's a few different ways you can do this, and that's what makes that activity so great.
Okay, I'll just jump in, I suppose, if that's okay. So I also have done a number of these different activities, and I wanted to add to the very first one, the one on clouds, that there's a great activity on the clearinghouse investigating the insides, where you're building a cloud in a bottle, and I'll drop that here. And we did that as part of a just a general weather program. We had stations set up, and we had cloud in the bottle, and this involves, we have to purchase a pump, unfortunately, but you put a pump and a tiny bit of alcohol into the bottle, and you pump it up. And when you release it, it actually creates, mist, and it changes the temperature too. So if you have a way of measuring the temperature, then that's actually very cool. So we did that as well. So it's another thing to add into the into that particular thing. The other one, the Mosquito Habitats. There's a mosquito trap that you can build that's also on the clearinghouse. It is a ambitious take and make if you wanted to do it as a take and make, because there's a lot of parts, and but it's also very satisfying if you're doing it for a little bit older kids, because they'll take it and they'll modify it and they'll do whatever they want with it, and it's very, very cool to see that happen. And that was kind of our experience. We didn't have 100 people who signed up for that one, but we had fewer people, but the things that they did were pretty cool. And some of them modified the habitat, because as we sent it out, it was tricky to make it work. But when they fixed it, it worked great. And so that was kind of fun to see too. So yeah, those were the two things I wanted to add to that.
Great, thank you so much, Kevin and Atlas. It was fun watching the poll change a little bit as you all were talking. Atlas, I think you sold some people on the investigating the insides activity, because that started to go up as you were describing your experience. So I'm going to end that poll and share the results so you can all see. Happy to see that every activity was selected at least one time. It does look like the building for hurricanes is the most popular choice, which that was the same for yesterday's group as well. Those engineering and design challenges are just so much fun to do. And a lot of people, like I said, I think Atlas, you convinced some folks to choose investigating the insides. And Kevin, I'm so glad you mentioned some of the other activities. So these are just 7 of many activities on the Our Blue Planet Earth collection, some of which, yeah, Kevin mentioned. So if none of these activities seemed to be what you're looking for, please check out the Our Blue Planet Earth Clearinghouse collection, and that is on the link bank that's been dropped in the chat. And with that, I'm actually going to turn it over to Dylan to talk about a few more resources that can help you with the oceans of possibility or other times that you want to do activities about our blue planet Earth.
Thanks, Claire. So as you're thinking about our Blue Planet Earth programming this summer, the great landing page for you is the Our Blue Planet Earth event page on starnetlibraries.org. So if you go to, I will drop that link right here in the chat to take you to the event landing page. And what you'll find there is some great resources, a description of the Oceans of Possibilities CSLT theme, some links to NASA resources about ocean worlds, archived webinars about ocean activities, citizen science through SciStarter, the Globe Observer Citizen Science Public Training webinar, the link to the entire collection for the Our Blue Planet Earth, which I will also throw in the chat and is available as well in the link bank that Beatrice has been posting. And talking a little bit more about Globe Observer, all of the aspects of Globe Observer, not just the clouds, as well as resources from SciStarter specifically geared towards the library about citizen science. We have several book lists with water-related books, some promotional materials, printables, as well as collaboration opportunities and other websites you can visit, and supplemental videos that you can share to help you and your patrons understand water issues. We also have 3 different collections that I think would be really, really great to pair with some of these toolkit activities if you're looking for more activities to do with them. We've already, I've already put the Our Blue Planet Earth collection, which contains the toolkit activities as well as many more ocean themed activities. We have our collection for another water themed project that StarNet has been working on and SSI called We Are Water, which also contains water conservation and water-based activities. And we also have Globe Observer sets really whets your appetite for citizen science. We also have an entire citizen science collection on the STEM Activity Clearinghouse, chock full of fantastic citizen science activities for you to explore. And if you're interested in diving deep with Globe Observer actually has an entire toolkit which has featured activities, supplemental books, videos, materials, printables, and promotional materials for all of the Globe Observer programs as well. So all of those links are in the chat and also included in the link bank for this webinar.
All right, so you guys made it through almost an hour and a half. There are so many resources thrown at you there, but definitely check out that link bank. It has all the resources you can go through. And there is also our contact information. If you have any questions, please feel free to reach out to myself, Christine, or Dylan. We'd be happy to talk you through any ideas you have for modifying these activities. And the recording of this, I will be posting on ALA Connect at the end of this week, so you can always come back and review different parts of it. But yeah, thank you so much. Our next and final toolkit, which is about the James Webb Space Telescope first image, we'll be having an unboxing webinar for that in May. So that will be May 25th at 2 p.m. Mountain Time or May 26th at 11 a.m. Mountain Time. So again, we're offering 2 options for you to attend. Those registration links have not been made live yet, but once they are, I will post those on ALA Connect so you can sign up for our last toolkit unboxing webinar. Thanks to Atlas and Kevin for joining us and sharing their tips from the library world. And thanks so much to Christine and Dylan and Beatrice in the chat for helping with this webinar. We'll stick around for a few more minutes if you have any questions, but otherwise, please enjoy the rest of your day. And thank you for being NASA at My Library partners with us.
Thank you all for joining us. It's been so much fun showing off these activities for you.
Thank you. We appreciate all of your time and everything that you do with your libraries.
And please, if anybody, before you take off, if there's any questions about any of the activities we've done today or anything you want to just pick our brains about, please unmute and ask away.
Yeah, and once again, our next webinars, option 1 is 2 p.m. Mountain Time on Wednesday, May 25th. Or if you can't make that one, we'll do another one at 11 a.m. Mountain Time on Thursday, May 26th. And of course, if you can't make any of those times, the recording will be made available on ALA Connect.
No possible questions. We're that good at these webinars that there was no questions to be asked.
Great. Well, if any questions do come up later, definitely send us an email. And I think with that, we'll end the webinar. So thank you all so much and have a great day.
Thanks, everyone.